Hey guys, it's Miss Silva, and for this lesson, we're going to add and subtract polynomials. To be successful, we need to identify if the polynomials are being added or subtracted. So we're going to be looking at the symbol in between the two parentheses. Then we're going to combine like terms, and then rewrite the polynomials in standard form, which means we're going to write it from the highest exponent to the lowest exponent. Like terms are defined as having the same variable and the same exponent. For example, x squared and x squared have the same variable and the same exponent, so those are like terms. If we have x to the third power and x to the second power, those are not like terms because although they have the same variable, they do not have the same exponent. When adding and subtracting polynomials, you add and subtract the coefficients only. So when we are adding polynomials, so if there's a plus sign in between the two groups that we're adding, then that means we can just drop the parentheses or remove them, and then we can combine like terms. After we combine like terms, we write it in standard form. At example number 1, we have two groups. This is my first group, this is my second group. In between, we have a plus sign, which means we are adding them. When we are adding two groups, that means that we just combine like terms, so we can ignore those parentheses. So I'll start with 12m squared. I'm going to rewrite 12m squared, and then the term that I can combine with it is 8m squared. Notice how they have the same variable and the same exponent. Then we're going to go to the next term, which is positive 4. Positive 4 can be combined with the other constant, which is positive 5. So I'm going to write it right under it. Once we group the like terms, then we can just simply add the coefficients, that's 20, and we keep the variable and its exponent. With our constants, we simply add 4 plus 5 is 9. Let's go to example number 2. Again, we have a plus sign in between the two groups, so we're going to just combine like terms and ignore the parentheses. We start with m squared, that's a 1, and then its like term is 3m squared. There's no other like term, so we're going to go with minus 4, and then its like term is positive 5. So all we do is simply add 1 plus 3 is 4, keep the variable and its exponent. Negative 4 plus 5 is positive 1, and it's in standard form, so we are complete with this problem. Let's look at example number 3. Go ahead and try it, and then come back to the video. Okay, for example number 3, again we have two groups, and in between the two groups, we have an addition sign, which means that we can ignore the parentheses. So we're going to look at the term with the highest exponent, which is 4x squared. And if you notice, there's no other terms with x squared. Next, we're going to go with positive 3x, and then its like term is positive 2x. And then finally, we have negative 1, and its like term is negative 9. So once we group all our like terms, we simply add 4x squared, 3 plus 2 is 5x, and then negative 1 plus negative 9 is negative 10. Let's move on to the next one. Again, try this on your own before you continue. And let's start with the two groups. There's a plus sign, so we're going to add our groups so we can ignore the parentheses. We'll start with 2s squared, but if you notice, this one has a higher exponent, so let's write that one first. 2s to the third power. Now there's nothing else to combine it, so let's go on to the next term that has the s to the second power. So we have 6s to the second power. There's nothing else that has s to the second power, so let's continue with positive 3s, and its like term is negative 6s. And then finally we have positive 7, and its like term, negative 4. So once we combine them all, then we simply add. We get 2s to the third plus 6s to the second. 3s minus 6s is negative 3s. And then 4 plus negative 4. I'm sorry, 7 plus negative 4. Or 7 minus 4 is positive 3. And if we do it this way, we already have our answer in standard form, where we have the highest exponent to the lowest exponent, and then my constant at the end. Okay, so the next part is subtracting polynomials. Subtracting is the same thing as adding the term. So the only thing we need to do is we need to remove the parenthesis from the first expression and then rewrite each term. And we do not change the signs. Because if there's nothing in front of that parentheses, that means it's a positive. So we don't need to worry about changing anything. When you remove the parentheses from the second expression, we need to change each term to its opposite sign. After we do that, we combine like terms and rewrite in standard form. Let's look at this one, for example. Notice how we are subtracting the two groups. Now this group has no symbol in front of it, so it's positive. That's why we said that we just drop the parentheses. So we ignore those parentheses. On the second group, that means we're subtracting 8. So we're subtracting 8m squared, and then we're also subtracting 5, positive 5. This is equivalent to multiplying by negative 1. So if there's no number in front, there's a minus. That means we're multiplying negative 1. And negative 1 times 8 is negative 8m squared. Negative 1 times 5 is negative 5. So when we combine like terms like we did in the previous section, we use this new expression and we ignore the 1 before it. So let's start with 12m squared. There's nothing higher than that, so that's going to be the first number in my group. Now its like term is negative 8m squared. I'm going to cross that one off. Then we move on to m, there are none, and there we have 4, our constant, and then negative 5 is also our constant. So let's go ahead and combine them. We have 12m squared minus 4m squared. I'm sorry, 8m squared is 4m squared. And then 4 minus 5 is negative 1. Let's look at example number 2. Again, if we look in between these two groups, we're subtracting the second group. The first group, we can ignore those parentheses. On the second group, we're subtracting 3m squared, and then we're subtracting positive 5. So we're going to ignore this part, and now let's combine like terms. So we've got 1m squared. We can combine that with minus 3m squared. Then we've got minus 4, and we can combine that with minus 5. So then we can combine 1 minus 3 is negative 2m squared, and negative 4 minus 5 is minus 9. Let's move on to the next example. Try to do this one on your own, and then come back and check your answer. Okay, let's look at example number 3 now. We look at in between the two groups, and we're subtracting the second group, which means we're subtracting 2x, Then we're subtracting negative 9, which means we are adding 9. Ignore this first group, and let's go ahead and for x squared, there's nothing else to combine it with. So then we're going to move on to 3x and negative 2x. We can combine it with negative 2x. Then we have negative 1 marked constant, and we can combine it with the other constant of positive 9. So let's go ahead and combine like terms. For x squared, 3x minus 2x is 1x. Negative 1 plus 9 is positive. Finally, let's move on to the fourth example. We have two groups. We're subtracting the second group, so we're going to subtract 2s to the third power. Subtract negative 6x, which means we're adding 6x. Then we're subtracting negative 4, which means we are adding 4. Now let's combine like terms. We have 2s squared, but then we have 1 to the third power. So let's write that one first so we can assure that it's in standard form when we're done. And there's no other term that has s to the third. Now let's go on to s to the second. We have positive s to the second, nothing else. Then we move on to 3s, and its like term is 6s. Then we have our constant of 7 and the other constant of 4. We bring this one down, get negative 2s to the third plus 6s to the second plus, we're going to add 3 plus 6 is 9s plus 11. And when we do it this way, it's already in standard form. Your assignment is on Google Classroom. Please make sure that you show your work and you upload your work or turn it in with a sub. Good luck, and we'll see you all tomorrow.